It's an interesting name, Perceptyne. What does it mean? Where does that come from?
There are a few essential aspects of robotics. So perception, intelligence and manipulation. So perception and action. So action, the closest term that we can, sort of fit to have a good sounding name was dyne, basically force. We thought Perceptyne, but it sounds a little bit better, Perceptyne.
So obviously it looks like there are creative geeks who've come up with this name. So who are these geeks?
Yeah, it's mostly me and my wife.
And what kind of things were you building when you were in college, when you were participating in this competition?
Self-balancing bicycle. Built it for our technical festival.
Were you successful?
Demonstration scale we were successful, but I mostly wanted to get some experience in hardware. Hardware I think needs 3 to 4 years for you to be really mature enough to understand. A project is successful if it works once. A product is unsuccessful even if it fails once.
That's quite deep, yeah.
So to take it from this to this is what that 3-4 years.
Hi Ravi, welcome
Hi,
to
Pallav.
BotCast. Thank you for giving us your time.
Thank you for having me here.
How are you?
Good, Pallav, thanks.
2 years of development must be some exciting times.
Yeah. 2 years of very intense development, and development goes on, but yeah.
All right, let's get right in. So I've been told you call your robotic solutions industrial semi-humanoid robots. Is that correct?
That's true. Yeah.
There's too much technical terminology there. Break it down for us.
Sure. So broadly, industrial humanoids, that's what we are referring to, and lot of these industry assembly line tasks, product assembly tasks, which people do mostly with their hands, sitting at a place, right? So when we think of humanoid, we really primarily try to think of the locomotion, like two legs, walking, climbing steps, etc. Right? In an industrial scenario, that's not the most important feature to have, because usually these factory floors are flat, no stairs. In fact, intentionally designed to not have any potholes or anything like that, or speed breakers, so that people don't accidentally trip. So really, more than locomotion, the things that people do with their hands and eyes, especially dexterous tasks, that's what most product assembly tasks are. So I think the essential aspects of human, or a humanoid robot really comes down to being able to do product assembly tasks and object manipulations with hands, and that's the reason we thought industrial humanoid with what gels well with what we are building, where we are not focusing right now on the locomotion part and rather focusing on what you can do on an assembly line.
Is it effectively two arms with one coordinating body? Is that what it is?
That's true. Yes. Yeah.
All right.
So hands, eyes, a sense of touch and intelligence. That's how we want to put it.
All right. Cool. And it's an interesting name, Perceptyne. What does it mean? Where does that come from?
I think. So how it came about was more like, we want, there are a few essential aspects of robotics, right? Any textbook of robotics you pick up, perception is one, basically seeing, sensing the world, creating world models or an understanding of the state of the world is one, that's perception. The last aspect of it is manipulation, basically.
Okay.
Like meaning being able to pick up objects, like manipulate them, open them, close them, place them, etc.
Right.
The middle part, and probably very interesting part as well, is the intelligence part. So perception, intelligence and manipulation.
Okay.
So we want to take like intelligence, everyone talks about. Perception and manipulation are things which are very essential and less often talked about. So perception and action. So action, the closest term that we can sort of fit to have a good sounding name was dyne, basically force. Dyna is like the Latin or Greek, I forget, but for force basically, or action.
Right.
So we thought Perceptyne, but it sounds a little bit better, Perceptyne.
So obviously it looks like there are creative geeks who've come up with this name. So who are these geeks?
So it's mostly me and my wife, like at the initial stages of like, okay, what should we call this? Me
right.
Silo, right? So we sort of came together.
And do you have a co-founding team?
Yeah, of course. So I have
who are they? What's the story there?
Sure. So I have a very strong co-founding team. We're a total 3 founders: myself, Jagga and Mrityunjay. So me and Jagga were batchmates at IIT Madras where we studied together. Me and Mrityunjay were office mates where, in our first companies I worked with National Instruments. So
Okay.
I have a very, strong working relationship even before founding Perceptyne.
Okay.
All of us used to bounce off, startup ideas like, you have to do this, maybe this, maybe this.
Right.
This sounds really good, but, does it have the market? So all these things. So
Okay, you were thinking about markets even before you started out.
yeah, totally. In fact,
That's very unlike many of the entrepreneurs that I know around. So we first build the solutions and then find the problem.
Okay.
So
yeah. So in our case, I think me, Jagga and Mrityunjay, we've been in the hardware space in basically running startups or businesses for, each of us greater than 10 years. So in that sense, we are a little more, for the lack of a better word, mature, especially in the hardware space that, hey, this sounds super awesome, let's build it. So we've sort of moved from that paradigm to like, okay, we can build whatever we want, but does it really have customers? Does it really have the scale that we envision for the company? So I think that was the conversation me, Mrityunjay, and me, Jagga, we were having separately, and then this sounded like the right place, right time, right scale, and all of us are passionate about building visibly moving things. So if I can say, so sort of like hardware, like broadly speaking.
So before finalizing that, okay, this has market potential, did you ever actually at least build prototypes or anything together, or was it always let's break down the idea first, let's figure out the market first, and then get down to building even a prototype? Was it always that way, or did you ever build prototypes?
So we built prototypes as part of this journey. We built multiple prototypes, and we are a strong vision-driven company in the sense that building, one specific robot is one thing. It's, I would say it's one aspect of doing things. However, the scale for a extremely application-specific robot could be a little narrow, right? So our vision for the company is to build something which has that massive scale. So one motto that we sort of have for ourselves is scale and agility as SaaS, but in automation. Basically, we want to do for automation and robotics, or we want to get the scale and agility of a SaaS business into robotics and automation. That was like one defining statement for us. Basically.
All right. So you want to bring SaaS into hardware, the scale and speed
agility,
of SaaS into hardware as well. That's quite interesting. We'll get into that a little later, but I want to delve more into your co-founding team. So you said, one of your co-founders, Jagga, was your classmate at IIT Madras, is it?
Batchmate, yes.
Batchmate, yeah. And how was it? Were you always friends? Did you have fights or?
Yeah, I mean, we knew each other, at college. We were not like, thick, close friends or something, but we knew each other. Like we participated in a few competitions together. But we knew each other most, when we were batchmates for a brief period. I mean, roommates for a brief period at Bangalore. Like I was staying in Bangalore, working with National Instruments, and Jagga was also there working with with the company, Coca-Cola at the time. So at the time, lot of idea churning, like every day. Every day it's a new idea, from logistics to B2B marketplaces to anything. Like lot of these ideas we were discussing.
And what kind of things were you building when you were in college, when you were participating in these competitions?
Sure, yeah. So at college, I was basically super passionate about robotics. So we participated. We were one of the sort of only probably representative from India for international aerial robotics competition. So it's an autonomous drone competition back in 2008-9, even before drones were a very popular thing. So we built autonomous drones for indoor navigation. So the problem statement was basically like a drone has to start, it has to stabilize itself, and then it has to go into an indoor indoor environment, navigate itself, all that it had to do. And so like very simply put, a ground robot if you don't do anything, it will stay there.
Right.
A drone, if you don't do anything, it will slowly drift and crash into the nearest wall or object.
Right.
Right. So
Right.
that's a fundamental difference. So it means very active mapping of the environment and closed loop feedback on the environment to not basically ram into any of the walls or obstacles.
Right.
And while doing that, it has to basically navigate, figure out what is the best path, etc. So that was one. I also built, sort of a project or product, whatever you can call it, called self-balancing bicycle.
Okay.
So yeah, at the time that we built, it was probably one of the very few attempts made all over the world to build a bicycle that balances on its own.
Okay.
Right? So we built it for our technical festival, Shastra, back in
And were you successful?
Yeah, I mean, moderately successful. As in, at a demonstration scale, we were successful.
Okay.
Yeah, we unfortunately couldn't spend time enough to take it as a product per se. But yeah, I mean, for a good 10-15 seconds, it was balancing on its own, moving on its own.
With someone sitting on it?
With someone or without someone, both cases.
Both of them sound like promising products. What happened? And you could have started up right after college, right? What happened?
I could have, but I mostly wanted to get some experience in
Okay.
hardware. So hardware, I think this is what I keep telling, right? I think hardware development, product development needs experience. I think fresh out of college, maybe you'll be a very productive software engineer 6 months, down the line.
Yeah.
But hardware, I think, needs like 3 to 4 years for you to be really mature enough to understand what works, what doesn't work, what are the product life cycles, what are the support, life cycles, all these things. So I wanted to get a feeler for that. And
Wow.
yeah.
So
my first company, National Instruments, where again me and Mrityunjay worked together, was phenomenal at giving me that that experience.
So any students watching this, so take it from Raviteja, the founder of Perceptyne. If you want to be very good at doing hardware, right out of college might be very difficult. You might need 3 to 4 years of experience. So do keep that in mind. Is that a fair advice?
I think it's a fair advice. Yeah.
All right.
If unless you're probably exceptionally driven that from 10th class you've been building hardware, then probably you have enough experience by the time you graduate, or maybe 1 or 2 years.
Sure, that's still practical experience.
But still practical experience is needed.
Got it.
True.
And when we are talking this more specifically, are we talking about you needing experience even to understand hardware works for prototyping standpoint, or is it more around how do you build hardware that is scalable from a production standpoint?
Second one, yeah, scalability, production friendliness.
Right.
So the prototypes, in fact, can be done. Like
Okay.
I think college grads very well do, and they do
Okay.
build prototypes. What really needs that experience is basically prototypes are often very inexpensive because you build it in a way that it works for a few times. As one of my mentor puts it, a project is successful if it works once. A product is unsuccessful even if it fails once in how many ever
Wow.
thousands of
That's quite deep.
deployments,
Yeah.
yeah, right. So to take it from this to this is what that 3-4 years
Wow.
is. Yeah.
That's great. And what happened before IIT? Where were you? You sound like you had a lot of things going on even when you were in college. So obviously there's some backdrop to it. Where do you come from?
Yeah, I basically hail from Hyderabad. Almost all studied here in Hyderabad. Been a DIY maker since as long as I can remember.
What's the first hardware you built in your life?
A small bus.
Okay.
Yeah, a small bus with wheels.
Are you sure you built it, or was it a toy that your dad bought you?
No. I built it because I can tell you the parts out of which I made it.
Yeah.
The main body was a biscuit box, and the wheels were polo.
Okay.
So,
No, making that into a production scale thing requires a lot of knowledge there. Yeah.
yeah. So that was it, and the next thing, like I built a lot of things, but the next fondly remembered thing is a motor that I built.
Okay.
In grade 7.
This
As
is
like
more interesting. So, help us. How did you make that in 7th grade? I'm sure there must be some 7th grader out there trying to do something like that. Guide him now.
Yeah, I think today it's definitely much more possible with YouTube and everything around. But back in that day, there's one book. It was called 101 Science Games.
Okay.
By this guy called Raviteja. Again, an inspiration for me, when I was young. And he goes by his what do you call pseudonym called AIRA.
Okay.
I don't know why he chose. Maybe it sounds Russian and very popular, maybe, but his name is Raviteja, which I understood like very later. So the last thing there is making a model of motor out of nails, like basically out of nails.
Okay.
Like nails,
Okay.
like how do you? But it was far more challenging than that because the number of varieties of nails that he was asking in that thing, I was just not able to get all of them. So I had to basically break it down to principles and see, okay, if not this, what else can I do? If not this, what else can I use, etc. So I ended up mostly not using any of the things which he told.
Wow.
But yeah, basically having to make it.
And you ended up building a motor that worked.
Yeah.
And
loose one, shabby one, but it rotated.
Besides that book, who else was your guide or mentor? Was it your father, mother, or some other brotherly figure or someone?
A lot of people. I think mostly in the spaces that I was interested in, which is like engineering. Mostly it was these books, which were like.
And which one's your favorite book then?
There are many. This one, I mean, like 101 science games. Many like multiple experiment books. There's one called 71 science projects, and then like the typical JE books like Irodov and H.C. Verma.
Yeah, but
I really like that.
7th grade or 6th grade, that's not the one that you went to, I suppose,
right? There's one book called Fun with Maths or something like that. It's by this Russian author called Yakov Perelman. It was like very good. So basically, I think you get a sense of what I was. I basically liked math. Right. I liked building things. I just loved things
the easier term for that is a true geek.
Something like that, yeah.
Okay. And do you read fiction as well, or is it only academics?
I read fiction, but...
which one's your favorite robot?
Favorite robot? Okay. I've not read science fiction as much, but very few of that I've read. My most favorite story is this, what has been made into this movie called Arrival.
Okay.
Yeah, that's like very interesting concept. It's like very, very, like mental opening, mentally like, oh, okay, fine, this is really cool.
Right.
But yeah, but mostly like I keep my fiction too, like Harry Potter and like Lord of the Rings, those sort of things basically.
Okay.
Like, fantasy fiction.
Fantasy fiction. All right, that's cool. That's cool. And let's talk more about your co-founders. Obviously, you've worked with them for over a decade together with them.
Well, yeah.
Awesome,
yeah.
And so, when did you come together as a team? For Perceptyne specifically.
Sure. So yeah, I'll give an intro as well. So Jagga, like I said, has been my batchmate, and then we were roommates for a brief period. So we had different paths. So he joined Ashok Leyland, then did his MBA. Then he went to work with Ola. He led P&L for Vizag and for coastal Andhra regions, and then he's basically been a CTO for this EV startup called Boson Motors. It's a California, India-based EV startup. So overall, been in tech, been in hardware, likes building things, into operations and supply chain management, and like basically the the best operations / CTO / manufacturing person that I could think of.
Okay.
He was one. So this was something that I was recurringly bouncing off. Like every idea that we discuss, hey, like we ought to make this generalized platform for automation. It really has scale. Because the genesis for that was like, at one point I was interning with a company which was making vending machines. So the amount of custom automation that was going into these vending machines at that time, like there were very few companies who were making them in India. The amount of custom automation which was going into these is just too much, right? Some mechanism that works for lace packet doesn't work well for biscuit packet. Something that works for
that's why they always get stuck in the background.
Exactly. Right? So I was like, hey, there ought to be a generalized solution for this. What if there was a robotic arm with vision and with, I didn't have the term AI in mind then, but with intelligence, which can actually take computer vision feedback and actually, give it like a human, like a minion, right? That would be much more generalized. That would be so much more scalable. All the complexity or the continuous improvement work basically shifts to software.
Right.
That's a very powerful paradigm, at that time when I first sort of realized. So I was recurringly bouncing this off with Jagga, and like he's also seen many of these problems firsthand at Ashok Leyland production lines, and Boson Motors production lines, and it's like, hey, this is something that we really ought to work. There's definitely potential for this, and very similar story with Mrityunjay as well. So he's been BITS Pilani graduate from electronics background. So he's also built lot of like these geeky stuff, hardware stuff when he was at college. So he's actually 2 years senior in batch wise.
Okay.
And then so he's been there, done that, and then he's joined this EDA automation tool company called Synopsys. They're basically known for the semiconductor design automation tools basically. So he's worked there on USB IP, ARM IPs, etc. So post that, like that's a very technical applications engineering sort of role. Then he's worked with then he's done his MBA and worked for a brief period with Ernst & Young, where he co-authored the policy recommendation paper for what is today implemented as PLI incentive scheme for the electronics manufacturing industry basically. So at that time he firsthand saw the limitations, and he firsthand saw the the things that electronics manufacturing companies do, the kind of challenges that they face with, etc. And post that he joined NI, National Instruments. That's where we worked together.
Okay.
So he led like more than 100 applications engineering, configurations for and sales for National Instruments. Led some of the largest deals that NI had seen till then, etc. So at that time I had earmarked him. So again, like same thing, like, okay, can we work? Shall we work on this? This sounds good. This sounds good. Again, a recurring idea was like, hey, an automation platform, is something that we ought to build. He also took a brief stint at Coursera, then realized, okay, Perceptyne is something.
So you have two co-founders.
Yeah.
Along with you, there's 3 founders of this organization. All 3 of you are geeks, as in pure hardcore hardware geeks. Yeah. One of them led P&L for a company, Ola, in some region. And then there's another one who was doing policy recommendation for the government.
True.
So between all of these co-founders, I'm assuming you already have a sales pipeline that is a few 100 crore worth. Right?
True. In some sense, yes.
Yes. So obviously you're very smart with the way you've built out your founding team as well. Congratulations to that.
Thanks.
And then all of you came together when, in 2020, 21?
22.
22.
Yeah.
Okay.
Mid days around we came together and we thought, okay, this is the time.
Right.
Let's start.
And did you guys start working on any of the components even before you started full time on this, or were you just biding your time and then quit everything else, came here and then started working on this?
We were building components of it, but mostly at a experimentation level.
Okay.
But mostly we just quit.
Right.
Had a small couple of months of sort of transition period where we were like, okay, fine, these are the things we have to hand off, and then
So you had some chill time between job and startup.
Yeah, exactly.
Okay. And it's been 2 years now, correct?
2 years, yes.
How's life at a job versus a startup?
Life at our startup is like totally good. Like if you are, like I said, if you basically love building things, I think I can very humbly say we would be one of the best companies to work for in this region, or probably in India, for sure. Yeah.
That's nice. And how big is your team now?
About 20 people.
20 people. What roles do they function? What functions do these people work in?
mostly mechatronics
Okay.
is one. I mean, mechatronics is one, and AI and application development is
Okay.
one. Yeah. So the platform, the hardware is broadly mechatronics,
Okay.
where we build the robotic arms, build the end effectors or the hands, basically 3-fingered or 5-fingered hands, the sensors, etc. And the AI and software and application side of things, like, okay, like we've built these, we have to add that intelligence layer to, you know,
Right.
add that life and make it the suitable to the application that the customer needs, basically.
Right.
So broadly these two, and of course support functions like operations, admin, and HR, etc. Yeah.
So you're not talking about sales or marketing yet. Do you not have teams for them yet?
No, we do. So
Okay.
the applications team is basically morphing into sales team. That's a combination of both applications and sales.
Okay.
Yeah.
Okay.
Yeah.
Okay.
Because in this business, you need to be technical.
Right.
You need to be application focused. You need to understand the pain points of a customer, both from business standpoint and technical standpoint,
Right.
and architect a solution for it.
Right.
So there is no way we can decouple sales of effort
From a technical one.
AI and software and even mechatronics development effort.
Got it.
That's the reason we have this sort of structure.
So if you have two different customers with two different factory profiles, what's the percentage of customization that you might have to do for one versus the other?
Sure. So currently, because the platform is still being built, it's more involved. But in the long term, we expect almost no customization on hardware.
Okay.
And something like about 2 to 3 man or weeks of customization on software, basically. So
Okay.
that's basically how we intend to
Okay.
do it. Yeah.
Okay. And you're talking
Maybe.
about
3 to 4 man weeks.
Yeah.
That's the thing. And in fact, incidentally, that's the sort of like the core USP of what we are building. And not just us, anyone who claims to be building AI driven robots today,
Right.
that's the key USP that they're talking about.
Right.
Robotics traditionally have been extremely unintelligent. Like, you ask a robot to go to a position, it will go to that position.
Right.
If there is a wall in between, if the object is not there, the robot just doesn't care, just blindly goes there. If something is there, it just either breaks it or
Right.
breaks itself, or just if it's slightly more intelligent, it'll stop there. That's
Right,
it.
right, right.
But it doesn't really go out, reach out, intelligently pick up this bottle, open the cap, close the cap, and put this back.
Right.
That's how traditional robotics has been.
Yeah, but is that necessarily wrong from a factory standpoint? Because we see a lot of videos even on Discovery where how things are made in a factory and things like that, and they're precision built for if you want to open a bottle cap for whatever reason, or if you want to close it after filling up the
Liquid,
soda,
yes.
it closes it naturally and without any problem so far.
True.
So why is that wrong?
True, that's not wrong actually. Like, that's indeed very good and very successful over the past 3 decades.
Yeah.
What I'm saying is, it has reached its saturation.
Okay.
The next 2 decades are about AI driven automation.
Okay.
Right? So the bottle soda, canning example, right?
Right.
Like, you pour the soda liquid, etc. They're like extremely automated. FMCG, for example, is extremely automated.
Yeah.
One of my friend works with a very large FMCG company, and the product that they make, which a lot of people consume, the number of products made every minute is 18,000. That's a small product. 18,000 of those are made every minute.
So
just
effectively
300
per second, yeah.
basically.
5 every second.
Yeah,
Okay.
so that requires extremely purpose-built, highly sophisticated automation systems.
Yeah.
Right. Bottle, closing, like canning, etc. Very high volumes. They require purpose-built automation. Right. So typically, automation has been successful there for very high volume, low mix sort of scenarios. Right. But a lot of products we use daily, your mobile phone, this camera, that light, or infotainment system of a car steering subassembly, headlight subassembly, they still have lot of dexterous manipulation tasks in the product assembly.
Okay.
And the product is not that high volume that it justifies a 5 crore investment into automating that.
Okay.
So those have not been, automated. Those did not reap the benefits of automation, right? And those tasks that need high dexterity, have a lot of variability, are the things where AI with the right hardware platform can really do wonders. That's basically what we.
So is this something that Elon Musk was talking about when they over-automated their factory and then they had to undo some of that and bring physical people in?
Precisely, exactly that. In fact, so they in fact tried doing a lot of these automotive, installations, and so automotive. When we think of automotive and robots, we tend to think like, oh, okay, everything is automated. There is this big yellow or orange robot. We just keep putting things. That's like the first part of the build of the like the car, right? That part is heavy lifting. That's automated. However, after that, installation of the seats, the infotainment, the steering, and a lot of these things, and the wiring and everything, that's still manual. And that is one thing that they tried automating. However, there are certain technology limitations, in terms of, again, bordering on how unintelligent robots are and how much intelligence can you really embed onto them. So I think 4 years ago, that was indeed still a challenge. But I think with the latest advancements on AI and compute power, I think that's slowly, sort of dissolving. AI is becoming better. I think no one would deny that. And that, when applied to physical robots, will definitely solve these problems in a much better manner. I'm sure Elon Musk also realized that that's the reason they have so much work going on. Tesla Optimus. So he's seen those problems firsthand. He's gotten, good.
Does your robot have a name?
It does have internally.
Okay. Come on, it's a small thing. You've got to give us that.
So internally we call it Ramana.
Okay, that like, quintessentially Telugu name. What was the story behind that?
So it's if you're a movie buff, or any of the viewers is a movie buff, they'll understand. So one of the applications that we were considering at some point in time was a load lifting application. So lifting, something.
Okay, this reminds me. So Pushpa is the reference, I suppose.
I think it's Sariler Nikevro, no?
Oh, okay. One of the
Mahesh Babu movies.
Okay.
So, and Ramana Lodettal is like, that was like, all of us are also movie buffs. So we have that thing.
I hope you've paid royalty for that name.
That's internal. But externally, we're calling it PR34D.
Okay.
PR for Perceptyne robots, and 34D for 34 degrees of freedom that are humanoid robots.
Okay. And so how does your, how does Ramana typically work? So what are the different functions it's capable of doing?
So it's basically a dual arm, 7 degree of freedom on each arm, and 3-fingered end effectors. 10 degree of freedom on each hand, with 4 sensors, tactile sensors, and most importantly, visual feedback and AI. So that's the gamut of technologies that go into PR34D. And so so the as we are building, basically these elements that we're putting together, once they mature, the way would be that operator demonstrates or teleoperates the robot to do a task. Let's say the assembly line task which I have is basically take the cap and put it on this and put it aside. That's all. Assembly tasks are very simple, right? Like the input is, components are there on a conveyor or in a tray given to you. Just pick those components, do some small 5-second task.
It's an orientation program.
Exactly. Like pick and manipulate, and then do some action, and then place it on the output bin or the conveyor.
Got it.
Very simple tasks. So the robot, when it's deployed, the way it is intended to be used is our applications engineer or the operator in the more mature case teleoperates. There's like a small, you can think of VR gaming suit that he probably wears. And then he moves, the robot also moves. And then he does the task.
Sounds more like Avatar. He's sitting inside a robot and moving it. Cool.
He does it. he does that maybe 50 to 100 times, and our AI basically learns how to intelligently do that task autonomously.
Oh, so why 50 to 100 times? Does he also does odd cases of, what not to do as well, or is it?
Sort of, like basically multiple styles of doing the same task.
Okay.
So that the AI knows that, if you just have one or two samples, we don't really have a lot of information for training the model basically.
Okay.
And the AI cannot really resolve or generate how to do that task.
Got it.
Once you have 50 or 100, you have enough data to reasonably discern what's variant and what's invariant between these iterations of tasks.
Right.
And you can generate the profile or the series of actions which does the task that you want and not do any unintended tasks.
Okay.
Yeah.
And talk to me more about these AI models. Are these homegrown, or are you building on top of something that exists out there? What kind of AI modules are you using?
Sure. So we're basically doing both. There are certain, open source, very extremely powerful AI models in the imitation learning space, as we call them. So imitation learning is broadly the field under which we are talking about.
So imitation learning is an AI is a field of study in AI.
Field of study in robotics and AI.
Okay, what does that do?
Basically, you imitate or demonstrate the actions like I said 50 to 100 times, and the robot learns how to do it.
And where is this imitation data coming from? Is it fed through sensors, or is it based on vision?
Both, yes.
Okay.
Yeah. So you teleoperate the robot, and during that process, you collect all the data,
right?
Visual feedback, segmented visual feed, the force sensors, tactile sensors, your own joint feedbacks, and everything you collect, and you basically give that to your AI model.
So imitation model is one, and then
and then multiple other models. In fact, many of them pertaining to computer vision. So there are multiple open sourced models which are available out there, and what we are doing is building on top of it for better robustness for the applications that we are targeting, and better ease of deployment for the applications that we are targeting.
Got it.
So
for our DIY enthusiasts, why don't you give us some of the model names that you are working with, the open source models?
Sure. I mean, there are these models like I said, there is this imitation learning model called action chunking by transformers.
Action chunking by transformers.
Yeah. So that's one. And Facebook has Meta has multiple of these image based segmentation models, etc.
Okay.
These are the things.
Okay. Okay. So primarily you're working on imitation learning, and second is computer vision.
Computer vision. Yeah.
And this basically encapsulates most of your AI.
That with what we are doing internally, especially in terms of task planning.
Okay.
That encapsulates.
Okay.
That is the thing which we are building, which adds a lot of robustness to how we are deploying this.
And robots. Will I ever be able to talk to Ramana like OpenAI? Ramana, do this or bring me that.
Yeah, I think in future, yes.
Okay.
Yeah, but right now where we are, our focus right now is in industry. Because contrary to what most people think, industry is actually easier to target as opposed to domestic use cases. Domestic use cases have a lot of variabilities.
Yeah,
more just generic, ask it to make green tea for me. Right from the task of where is green tea, do I have it or not? If I don't have it, should I order it on Instamart or Amazon? There's so many variables, as to how we plan and execute things, and how we go about that. I think we're not there yet to attack that problem.
Okay, so you're sticking to immovable semi-humanoids at this point.
As of now, factory-based humanoids. Yeah, not necessarily immovable, with mild movements if need be. But industry settings where things are a lot more organized, where people will just not your 7-year-old kid will not just, throw in something.
Fair enough.
Just for.
But how does this guy move? I thought it was static beneath the waistline. Right?
Yeah, I mean, as of now we built it that way, but there are a lot of these off-the-shelf mobile platforms onto which it can be mounted and for minimal mobility.
Yeah. Got it. And let us take one step back. So you're talking about 10 degrees of freedom per finger, right? Explain a degree of freedom as if I was a 5-year-old kid.
Sure, no worries. So basically, this is a degree of freedom.
Okay.
This is another degree of freedom.
Okay.
This is another degree of freedom.
Okay.
This is another degree of freedom. This is 1 degree of freedom.
Okay.
So like that, our arm has 7 degrees of freedom,
Okay.
right? Fingers have many more degrees of freedom.
Okay.
In fact, it's hard to even articulate exactly how many degrees of freedom we have.
Right.
It's a very nuanced question. But yeah, we have as many degrees of freedom, at least as many as number of fingers into 2 or 3, right?
Okay.
Yeah, that's.
Is it primarily a function of movement only, or does sensing also become a part of DOF?
Primarily movement only. Yeah.
Okay.
Primarily movement.
Okay.
And the reason degrees of freedom is important is that today's robots are mostly filled with 0 or like 1 degree of freedom. Move like things like, for example, a vacuum suction-based gripper or a 2-fingered gripper.
Right.
Now, if you imagine these robots to do something as sophisticated as taking the phone cover of your phone, or installing the phone cover of your phone, or opening the mobile phone or assembling, it's just not possible, right? So you need that manipulation capability with so many fingers and degrees of freedom, so that you can hold an object in the desired orientation and manipulate or change the object in desired orientation. That's the reason degrees of freedom is super important.
Okay.
You cannot open this bottle cap with vacuum grippers.
Okay.
Right? It'll just simply slip out.
Right.
Right? So that's basically what we are trying to say. Yeah.
Got it.
That's the reason degrees of freedom are very important. And to some extent, that's traditionally been an underrated, let's say, field or approach, which now I think a lot of these companies, including us, are focusing on.
Got it.
To make sure that we have enough degrees of freedom to do most of these assembly line tasks with at least nearing to the dexterity of humans, if not equal.
Wait, why nearing the dexterity? You said humans have 7 degrees of freedom and your robot has 10 degrees of freedom.
So
it should be more dexterous.
Humans have a lot more actually. Like I said, humans have like anywhere between, you can say, 20 to 25 degrees of freedom in the hand. Basically.
Okay.
I'm saying at
Each
least.
finger. Okay.
Like there are various definitions of how you define degrees of freedom, and different people who flex their muscles in different way actually acquire a little more degree of freedom.
Sure, acrobatics will give you more
exactly.
degrees of
Like some people can move their abs, some people can't, basically.
Right.
So yeah, so depending on how you train your hands and muscles, you gain some additional degrees of freedom. So what I'm trying to say is, it's a nuanced question and we have at least 20 degrees of freedom.
Sure. So what you're also telling me is doing yoga gives me more degrees of freedom.
Yeah.
All right. Fair enough. So 10 degrees of freedom for your hand, but then you also said your robot comes in a 3-finger configuration as well as a 5-finger configuration. What's the difference? Why do you have 2 different configs?
We at least need 3 fingers for doing most of these tasks.
Okay.
And we probably don't need, like for 95% of the tasks, 3 fingers are sufficient. And 3 fingers basically means 2 less fingers to fail, either in on the field or after 2 years of deployment, etc.
Right.
So the lesser the number of moving components, or the lesser the amount of anything we want to have,
right,
we would want to have that, because that means it has to be just as simple as possible, but not simpler.
So delete everything that's not needed.
Exactly. Yeah. So, and that's the reason why a 3-fingered configuration. And because there is so much, traction that people are building for these 5-fingered hands, the core essential technologies that we built for 3-fingered can be extended for 5 fingers as well. And for people who already have their AI models built around some of these 5-fingered grippers or etc., like we want to plug in directly onto that, and that's the reason we have a 5-fingered variant, or we would be having a 5-fingered variant.
Got it. And obviously looks like there's a lot of technology, a lot of AI, a lot of mechatronics, so many different parts involved in this. And you've been building this for over 2 years, so it must not have been an overnight journey for you. What is the hardest problem that you've encountered while building this? Technical problem.
Hardest technical problem. I think overall, hand is extremely, it's very small, but it is the most sophisticated.
So when you say hand, you
instrument
mean
we have.
only this part of it,
Yes,
the palm
this,
essentially. Yeah.
palm plus 5 fingers.
Okay.
Yeah.
And what's,
Biologically, this is arm, this is hand.
yeah.
I also knew the distinction only after working on it. Yeah.
All right. So what's so complicated about that?
That's what. So the number of degrees of freedom packed into such small volume, giving the force on the end effector and giving you the high amount of tactile sensing. Like we have 5 different kinds of tactile sensors, right? One tactile sensor that is for low frequency pressures, another tactile sensor for high frequency pressures, which is particularly suited for detecting, some movements of objects. So there are 5 different mechanoreceptors, they are called, all of them packed in this volume. There are, like I said, anywhere between 20 to 25 degrees of freedom with extremely high forces, grasping forces, packed in this small volume. Anyone who is technical will understand that the friction coefficients of the tendons that are there in hands is like 1 order of magnitude than the best material that's available today.
Okay. An order of
10
magnitude,
times
okay.
smaller, right? So it's just not possible to achieve what hand, or it's not easy. It's extremely challenging engineering to build the hand part of it. Arms are easy. Arms are like, compared to hand,
right,
arms are very easy. It's another thing that there are very few companies building even arms in India. Like just 1 or 2 or 3 maybe, that's it.
Right.
But hand, there's actually no one building the hands, from India, and that's a very essential aspect of production. And in fact, so for those who follow this space very closely, in a very recent podcast, Elon Musk said the exact same thing, and I was like, okay, this is pretty insightful. Yeah.
And when you're talking about sensing, what kind of material goes in here? Is it just sensors attached to metal directly, or do you have any biomaterials that you're designing?
Soft materials we do have. So it's not metal, because metal doesn't have friction coefficients to hold objects. So this is like a rubber covering. So sensors are actually inside, basically. Yeah.
Okay.
Yeah.
Okay. So it's just a piece of rubber with some sensors attached, and rubber sort of organized just in a way to give it additional degrees of freedom. Is it?
Yeah. True.
Okay. Okay. And what if I wear it? Will I become Thanos?
If you control it, maybe you will. Like I said, you have a VR glove, so you can.
Right.
Okay. Yeah. If not Thanos, I don't know.
That's a good market that you have, right? So since you've solved, a good chunk of that problem, just put it on an exoskeleton, give it to me. I can go around punching people now.
Yeah. It's just that, like I said, it's hard to get the highest forces. The humans are actually better in terms of the highest grasping forces.
Right.
Basically, we have what is it called? Chemical actuators, like chemistry-based actuators, which have much higher power density than electromechanical actuators.
Okay.
Right. Muscles have extremely high strength to weight ratio. Significantly higher than electromechanical actuators.
Okay.
Electromechanical actuators are basically motors.
Correct. Driven by batteries and such.
Chemical, like basically biochemical, whatever you call it. I don't know.
Right.
So those actuators, like muscles, have much higher, for the same weight, you have much higher force that they tend to give.
Are you doing any research towards that end?
Not right now. That's
anyone else in the market?
There are academicians. Many academicians doing research in that end, but I think all of them are like at least 5 years away.
Okay, 5 years is not a long time.
Yeah, but if you want to be in market today, that's a long time.
Okay. All right. So, what are the lowest hanging use cases for Ramana today?
That I can give you the broad area in which we are handling. Broadly tackling production tasks for electronics manufacturing automation, basically. Yeah.
This reminds me. So, I don't know if you've watched this. There's a series called Silicon Valley.
Yeah.
Where there's an assembly line of phones that essentially it's farming, right? So they are tapping on and off and on and off and on and off.
Okay.
So could I potentially build a farm of smartphone activities using Ramana?
Oh, no. I now see where it's going. I want to tell that no.
Okay, so that is possible.
Yeah, I mean, of course it's possible. Like,
Yeah.
but having said that, yeah. So we mostly focused on assembly tasks,
Right.
basically putting together.
Is he already deployed somewhere? Is it in the market today?
We have some early stage conversations and proof of concepts going on.
Okay.
And yeah, so that's one thing. So the overall journey, especially in the hardware space, takes basically that time and that maturity,
Yeah.
to basically get to the customer. And we are at that phase where we are ready for doing these initial proof of concepts with the customers, and we have
Right.
some strong conversations going with, globally known, manufacturing players.
So,
and that's the.
I mean, you
that's the
said it
case
takes
for
that amount of time. Is it, how much of it is a function of ongoing research versus availability of parts versus, what are the different components that constitute that 2 years?
Actually, both. In fact, probably like very succinctly put, exactly both of them. One is, in our case, we are indeed building like frontier technologies,
Okay.
that multiple companies like Tesla, Figure, and multiple other European or Chinese companies are actually trying to build. So we are building them, albeit in a slightly more industrial, like I said, industrial usable manner.
Right.
We are building technology that's at par with these global leaders, with a very small team. So that's one. So the hardness of the problem is definitely one.
Right.
Second, it's basically accentuated by the fact that hardware physically takes time to import. Every manufacturer has their lead time. You want to import something, some magnets, some motors, everything has lead time. So basically the development cycles, so this is what I think even before when we discussed, right, in hardware, it's not an okay thing to fail fast or break things and move on, basically, because there are some things which just take time to put together if you break things. So
Right.
I would rather want to, like I said, we have some in-house machines.
Right.
I would rather put an experienced person than a very enthusiastic fresh college grad on it, right? Because if that machine breaks down, it's like 2 months downtime for me, right?
Fair enough.
So so lead times on procuring parts and like just machining things, manufacturing things, which basically means that you have an idea. For you to test and validate that idea, it's this much time, right? Now, having said that, at Perceptyne, we are very conscious about it and act with war level sense of urgency on translating ideas to prototypes and testing.
Okay.
Right? So much so that like I said, we own many crucial aspects of these manufacturing. We own these assemblies, we own the design, so that the entire cycle of design or idea to validation happens 1/4 of the time than
A normal company.
many other companies that I've seen, basically. Yeah.
Okay, got it. So how much of Ramana is made in India versus imported?
So first, that's a very interesting question and a extremely nuanced question. A lot of people, it's very hard to put a percentage, frankly, because like ICs, right? None of them are made in India. Like everyone knows, like that's what we're trying to. Government is trying to push for now, but they're all designed in India.
Okay.
So designed in India by an American MNC, made in probably Taiwan, and then used here. So
Okay.
so exactly what value add happens here, I think, is a very nuanced question. But one thing that we can say for certainty is definitely one of the highest in Indian industry today, to the level that none of the components which we use are particularly made for robotics.
Okay.
Any of the submodules or any of the components, they're all generic components.
Okay.
So basically, we are taking generic available components and building a robot out of it.
Okay.
Right. So I mean, there are a lot of people, who build robots from robot joint assemblies, for example.
Right.
Like, they get these CKD kits from, China or Europe or, many of these countries, and they basically assemble the robot out of it. That joint is a robot joint.
Okay.
It's a robot part.
Right.
If
So
you do that
essentially the
similar
whole part
analysis
itself
for
is
us,
imported.
yeah, I mean, the core parts are imported and
Yeah.
the last mile addition is done.
Yeah.
Or in many cases, people just import the entire robot and do the software addition here.
Okay.
Right. In our case, none of the components which we are using are exclusive for robotics.
Okay.
So that's the level of grounds of component development we are actually building from there.
Okay.
Yeah.
And
so I can say highest amount of value addition happens here.
got it. And how much does Ramana cost today?
That unfortunately is something that is confidential right now and evolving.
Okay.
So yeah, definitely.
I'm more interested. So the
due
reason
time,
why I
yeah.
asked that is, you said almost none of the parts are built specifically for robotics.
True.
And a whole bunch of parts are imported from outside,
True.
irrespective of where they're designed or scaled. Now, my question is, if every component was made in India, and if you had an industrial scale development of these parts that you're specifically using in Ramana, by how much would the cost of Ramana come down by? Would it be 40% cheaper or 10% cheaper, or no cheaper at all?
Actually, so the cost, we have a compelling cost structure overall because we are doing vertical integration of
Okay.
these robots, but that's not because we are making it in India,
Okay.
but because we have fundamentally different approaches.
Okay.
Right? A lot of people focus on precision. Robots is synonymous with precision.
Right.
Most industrial robots or even collaborative robots that you take today, they have like a 20 micrometer positional repeatability.
Okay.
This is 1/50th of a millimeter. When you command, it goes to the same
Right.
position within 1/50th of a millimeter. Now to pick up this bottle and open the cap and place the cap, why do I need 1/50th of a millimeter of positional repeatability? I actually need something else. I actually need visual feedback, I need force feedback, I need tactile feedback. It's actually better addressed by having such a vertically integrated system. So that's forming the crux of what we build at
So
Perceptyne.
effectively, you're
And
talking about the opposite of precision, perhaps, in a sense.
True.
You want more flexibility and dexterity rather than precision.
True.
Okay.
So what we want is functional accuracy, not
Right.
positional accuracy.
Right.
We don't want the robotic arm to just blindly go to this position irrespective of whether there's bottle there or not.
Right.
We want the robot to intelligently know where the bottle is and reach
Right.
out to the bottle rather
Right.
than that position. So
Got it.
functionally accurate, positionally not that.
Right.
Need not be accurate. What that does for us, it significantly reduces the cost of the components, etc.
Right.
So we can fundamentally approach our business models. Everything will be facilitated by a highly cost optimized sort of structure.
That I agree, but that is at a engineering level or product level decision that you're making. I'm purely talking about the economic level of the state of the ecosystem itself.
Sure.
So if some of these parts were made at scale within India,
Yeah.
would it be cheaper at all, or would it not make a difference to you?
Very much depends on the kind of component that we're talking about. If that involves a lot of manual assembly, of course it will be cheaper because of the lower labor cost structure here.
Okay.
But if they are already made in highly automated fabrication facilities,
Right.
Being in India or being somewhere else doesn't really matter. Like
Okay.
semiconductor fab, for example,
Right.
is extremely automated.
Correct.
I don't think whether you make it, outside or in India,
Right.
the cost would be very different.
Got it.
Because our strength is the high quality talent at a very affordable or globally competitive
Correct.
cost structure, which doesn't always apply to all industries.
Makes sense.
Right.
Makes sense. So your customer base now, the POCs that you're doing, are they within India or where are they based?
Yeah, I mean, within MNCs, one within India, one outside of India.
Okay, and when are you making the announcements?
Soon, I think.
And
I think
there's a
very
lot of
well said.
information. So there's a lot of information that he said is proprietary and does not want to reveal on camera. So I'm basically handcuffed at this point for a lot of questions. So I'm trying to extract as much as I can. But as you know, he's very articulate and very smart in terms of positioning himself. So I'll have to by some of the constraints placed on me. So how big is your market?
So the electronics manufacturing market, if we take, or electronics plus automotive manufacturing market, uh, that's basically growing. It's a highly growing market. I
Right.
don't have the numbers exactly right now at the top of my head, but it's growing at an extremely fast rate of like 45% CAGR over the next 5 years, right? So that's the growth with which, I mean, that we are talking about. And the market of this generalized autonomy that we are talking about, that is much bigger. So
I mean, I would assume efforts like yours should actually add to that growth rate, right? It's a
definitely,
general growth rate expected today, but if there's
Definitely.
more automation coming in, then that 45 could well turn into 60 or 80 depending on demand.
definitely, yeah.
So yeah,
And-
considering all of that, if I mean, I was coming at it more from the standpoint of how many robots can you sell within the next 2 years potentially if everyone was deploying this?
Yeah, next, probably 3 to 4 years, we have like a goal of having 1,000 robots deployed.
Okay.
Yeah, so that's sort of like a goal that we have set for ourselves. Yeah, so so many number of robots probably in the US or the EU, majority of them with something like a service model, robot as a service model, what we
Right.
call.
But 1,000 in the larger scheme, I mean, when we think about it, when we are putting it in the perspective of cars, for example, we are talking about companies selling millions of cars.
True.
1,000 robots in 4 years doesn't sound like a lot. Is that market capacity or is that
No, that's
the
more
production?
of how fast we can grow
Produce.
capacity. Yeah,
Okay,
we can
okay,
grow
okay,
and
okay.
mature and produce.
Okay.
So something like that for 3 years. But like I said, the inflection point really comes about after that,
Right.
where we would have perfected a lot of these automation or the AI aspects of these things, where
Right.
you can talk, like you asked earlier, you can actually tell it, or with like maybe as few as 5 or 10 demonstrations,
Right.
the robot would just be able to do things in a very robust manner. Once
Got
that
it.
is done, the scope really is not just electronics manufacturing or automotive manufacturing, but subway sandwich preparation, e-courier
Oh.
commerce,
Okay,
parcel
so that's when
packaging.
Ramana will start getting legs. So
Yeah, that's-
semi-humanoid or
yes,
full humanoid at some point?
Of course, yes.
Okay.
So we will have locomotion at that point, and most importantly, the scope of the applications really explodes to sandwich preparation,
Right.
airline meal tray preparation. Every single airline meal tray that we consume on any domestic
Right.
or international flight is assembled manually.
Okay.
Right? Every single tray that we have eaten is loaded into the dishwasher manually.
Okay.
The garbage collection is done manually.
Right.
Garbage segregation is done manually.
Right.
There are so many places where generalized dexterous manipulation and autonomy finds its application into, and that is our canvas.
So essentially, at some point, we are talking about Ramana facing off in a cage battle with Optimus as well as Figure.
Very much, yes.
Okay, that's going to be very interesting. So we are talking about the
It's just the approaches, how different people choose to do it.
right,
They've started full-blown humanoid from day one.
right,
We take a more pragmatic approach.
Right.
Okay, like let's stick to semi-industrial humanoid robot. Maybe one arm, maybe two arm. Like I said, in fact, our aim is not to build the best possible humanoid robot.
Right.
Like most anthropomorphically, like very much like human, like
Right.
facial expressions. That's not our goal.
right,
Our goal is that humans are really good when it comes to manipulating things and intelligently functioning in the physical world.
right.
And the essential aspects of them we want to capture into our robot. So
Got
our
it.
approach is more pragmatic, more grounded. Let's do these. Let's create what is value for customer today with the long-term vision in mind, and slowly navigate from point A to point B. That's sort of our approach.
Okay, fair enough.
We're not Tesla that way, that we have hundreds
I
of
mean,
billions of dollars.
I have all these wild imaginations, right? So now if you're putting Ramana and Optimus in a cage fight, right, who would win? Right? So who would be stronger? Who would be more functional that way for a cage fight?
I think, yeah, if we have what do you say? If you have some way to strategize, I think the kind of things that we can pull off will definitely,
Right.
innervate or
So robo wrestling coming up in 2026 perhaps. So, all right. And so obviously,
in fact, a lot of these things, like for example, like in fact we've had a few customers like asking us for, okay, can this be used for these bomb disposal sort of thing, because bomb disposal often requires highly dexterous and it's extremely dangerous,
right.
Like you're putting humans in such unsafe environments. Bomb disposal, nuclear waste or fuel handling, bio hazard handling, basically. Like in fact, a lot of these vaccines basically are neutered live viruses, basically. Once live, neutered now. Sort of viruses. So extremely expensive affair for a person to go into that facility and come out of it. Like we've heard, prices ranging as much as 3,000 to 4,000 rupees if a person has to come out, because first he has to be completely sanitized, both internal contamination should not decontaminated, internal contamination should not go outside, and vice versa. And the water that they use, in fact a lot of time the air that they use for decontamination, the water that they use decontamination, they cannot just mix it with sewage. They have to actually treat it. So every bath or shower or air shower that you take before going into that is expensive. The PPE equipment is extremely expensive. So we've had people asking us that, hey, like I teleoperate the robot from outside, or my operator teleoperates the robot from outside. Is there something which you can do so that I can my expense of making vaccines comes down, my expense of handling nuclear fuel or nuclear waste comes down. So
that's an amazing use case, right? So at this point you're talking about perhaps even tens of millions of these, cleaning up our sewages or helping the defense in sensitive areas.
It'll not be tens of millions for sure. In fact, that's the reason why we thought about it, and then we thought, okay, this is probably not the best time to get into it, because the use case hardly will be a few tens. Again, the North Star for us is that we just don't want to build the coolest robots out there. We like building cool robots, but that's not what guides us in making decisions. Okay, how many people, what is the scale and impact of it? Okay, and if the scale and impact of it cannot give us that growth in the short term, we'll probably not be successful as a company. And that's the reason we have to choose our stepping stones very carefully. And I'm not saying we won't do it. We will do it probably, but it's not this time.
Okay, got it. And how are you funding all of this product development?
We're seed funded by some of the well-known names in the industry. We've received angel funding as well as from venture capitalists like who are into the space.
Who's your blue-eyed investor?
Okay, I mean, if you're asking famous, so we have investment from Bharat and Pawan of Skyroot Aerospace, and
that's nice.
Tarun and Tarun Mehta and Swapnil of Aether Energy. So in fact, I've worked with Skyroot Aerospace, and I have sort of worked and like at college and even later. I know the founders know me. Aether Energy founders know me well. So
got it. That's nice. Okay, so you've come to a stage where you are now able to commercialize your product only off of seed money.
I'm sorry? Yeah.
Seed round is the only one that you've raised so far, is it?
The pre-seed, what we call it. Yeah.
Pre-seed?
Yeah, that's what we've raised so far.
I'm just wondering what kind of money it costs to, build Ramana. Of course, there's three smart people, that's for sure, but besides that, what kind of money does it take to build Ramana?
I think more than money, it takes a decade of experience each Because frankly, like today there are government
It
grants.
almost feels like you're putting up barriers by, on purpose at this point.
No, I mean we had some government funding and multiple sources basically.
Oh, so were you incubated at one
Yeah,
of
we were
these
incubated
IIT Madras?
at T-Hub actually.
At T-Hub.
At
Okay.
T-Hub.
That's nice.
Yeah, and then there is this Startup India Seed Fund scheme,
Right.
and Nidhi Prayas scheme, etc. Like that, along with, like I said, the angel money that we've raised, etc. All that basically.
Got it.
But I'm saying more than that, it's the significantly more non-trivial portion of that effort is
Right.
the insight gathered over a decade of work.
Got it.
Or maybe a decade and a half of work for all of us. Yeah.
And is this all the money you need, or are you raising more money to?
We're raising more money. Yeah.
Where does that go? Where would that money go?
That would basically take us to having, a sizable number of deployments, something like 5 deployments or so.
Okay.
On the actual field, prove value to the customer.
So is it more around manufacturing is where you need that money?
Basically electronics manufacturing or automotive manufacturing. These are, like I said, the 2 areas that we're targeting. So we want the value proven to the customer so that we can raise the growth capital that is needed for the next.
Got it. Yeah. How does your manufacturing look like at this point? Do you have a separate manufacturing facility, or where are you doing this?
We are doing it in our office, like you've seen that, right?
Yeah.
Like, a good number of these components are made in-house, and many of them are made in either Balanagar or T-Works.
Okay.
So yeah. So T-Works is exceptionally helpful, in getting our prototypes, doing the iterations that are needed, etc.
Got it.
Yeah.
And
So overall, very much happy about on a related note, happy about the Hyderabad ecosystem, T-Hub, the kind of connects that they gave us, and the kind of traction that they gave us, and T-Works for the kind of manufacturing support that they gave, and the CIE of IIT Hyderabad for the kind of helps that they did in terms of talent finding, etc. All of them were.
So guys, there's a lot of hints there. If you are starting up, obviously, Raviteja is talking about CIE, Nidhi Prayas Fund, Startup India Seed Fund, T-Hub, T-Works. So there's a lot of these facilities that are available to you.
And in Hyderabad.
In Hyderabad alone. Yeah, that's the key word there. Yeah, all right. Cool. And so where do you see yourself, let's say 5 years down the line? What all will you be building? Who all will you be competing with? Who all will you be fighting?
I think we are, on a good track to build a global frontier tech company on the humanoid robot space.
Okay.
And the AI, for physical tasks.
Right.
AI today is good at chat input, chat output, text
Right.
input, text output,
Right.
or maybe audio input, etc., or image input or image output. But really, when it comes to putting together tasks or things in physical world, AI is still not there. I think we will be at the forefront of leading that technology and innovation.
So essentially, you will be at the forefront of displacing people from their jobs.
Seriously as you put it, that's in fact something that we keep thinking about. Are we, as a company, are we doing positive impact, or like as much as we can think? In fact, a lot of these trends, mega trends, etc., I don't think any single human really has the capacity to envisage everything. But I think we have enough reason to really, philosophically, we've discussed this a lot, and we have enough reason to believe that we are doing this is indeed very good in the long term. I'll tell you why. There are 3 to 4 key reasons. One, every time something is automated, the cost of producing that good went down, the cost of acquiring that good also went down, and hence the standard of living went up.
Okay.
You take automobiles, the Ford assembly line innovation reduced the cost of goods, made it more accessible, more affordable for automotive. You take the power loom, it made it more accessible. Clothes, basically, more accessible than what it was like some 300 years ago, right? You talk to similar thing about smartphones, right? The kind of things that once the cost of production goes down or gets automated, inevitably the standard of living for the mankind at large becomes better. That's one. Two, in terms of where we, the pace at which technology generally gets adopted or progresses, right? It's not an overnight thing, right? In the sense, in fact, if anything, it takes a couple of decades for really for the manufacturing or the jobs that we see today, for them to completely vanish. Even if they do, mostly many of them won't actually. Even if they do, it will take a couple of decades, okay, for them to basically, they will transition into new jobs. New jobs will get created, new jobs, the old jobs basically will go. So that job transition will not happen overnight. It will happen, over 2 decades. And also on a related note, a lot of jobs will never get automated. That to the best of, I might sound a little Luddite when I say that, but I will never be comfortable with a robot handling scissors doing my hair. Okay.
Come on, we are in the age where the greatest advertisements that hospitals are doing these days is robotic surgeries.
Robotic surgeries are all robot assisted surgeries.
Right.
They are the surgeon is there. Robot is basically assisting things, holding them in place. So
right.
I would see robot assisted surgeries as a doctor having 4 limbs.
Right.
Not really robot doing the surgery.
So it's essentially a Baba having 4 limbs that you're more interested in.
It's basically like the doctor is getting much better.
Right.
It's like, you see in this movie Avatar, right?
Right.
Like the person basically becomes much stronger.
Correct.
Like that, the doctor has like 4 more limbs.
Right.
To like, you want to hold this tissue at hand, you want to hold this, plate
right.
at hand, you want to, do some surgical intervention on this blood vessel.
Right.
Like you need 4 more limbs basically.
Right.
I'd see basically robotic surgeries as
and can we ever see Perceptyne giving us that, exoskeleton?
I can't comment on that right now. I don't really know. Not that I don't want to, but I don't really know. That's 2 reasons. I mean, coming back to that, the third reason why we won't immediately displace a lot of people, or is that like the second reason is that the technology transition won't happen overnight. And third, this is more of an India-centric statement, is that we've long been consumers of technology.
Right.
I think it's high time that we become developers and global leaders of that
that's
technology.
absolutely a brilliant statement. Yeah.
And I think that's the mindset with which we have to look at it. If we don't do it, I'm pretty sure some other company will do it, and we will again be consumers of technology. I think given the immense talent pool that we have, the production facilities that we are now raising up and everything, I think we have a very good position to be a global leader in this technology and global technology provider for this technology.
That brings up another important point. So, one of the new jobs that will be created will certainly be in either assisting robots or being assisted by robots to do something specific,
exactly.
Right? And in that sense, how are you finding the talent pool emerging in our country? Are we still stuck in that mobile and web app sort of an era, or are we moving forward? Where are you hiring from? How are these people being trained?
Sure. That's a very interesting question. So we hire some of the best of the lot that we come across, and they have a compelling problem to work on. A lot of these people are very motivated to work on challenging problems. And so in India, the talent pool, especially for building cutting edge hardware, is a little limited
at this point.
For sure. Because primarily we've had our successes at software, SaaS, and services, like significantly. So the talent pool is relatively minimal. But if you have the right compelling problem statement that you work on, the talent just gets attracted to that.
So you want more hardware people in the market today?
Hardware, like we do both. In fact, we have like a 50-50 composition of hardware and software. Actually.
The availability of software people is higher versus the availability of hardware people.
Is that to some extent? Again, there are a lot of nuances there. Like you said, if I want to develop a mobile app or a web-based app, I really get good talent. I mean, a lot of people might not agree with me because they're expensive. Okay, I'm sure, like I'm in these groups, our alumni groups, where people keep asking that, hey, like this software resource is becoming so expensive, etc. But still, the talent is available. But high talent for AI, especially purposed for robots, is still pretty hard to find. Again, in both of these places, because of the compelling product and the vision and the problem statement that we're working on, we've managed to get some really good people from top tier 1 colleges, all over.
India, so tier 2, tier 3 is still a challenge?
Not a challenge actually. Like we have, in fact, tier 2 tier 3 people. It's just that you have to be exceptionally motivated to work
It's like
on
finding
these things.
a needle in a haystack sort of a scene.
Yeah. So one of the colleagues whom we have hired from a tier 2 college, he actually built 5 of his own robotic arms, 3D printed like mini robotic arms, before we charged upon him and he charged upon us. So yeah, so if you are really passionate about robots, if you love building things,
Chalo, I'm asking you this on behalf of all engineering freshers at this point, right? As in people who are just coming out of engineering and looking for jobs in the market, or maybe coming out in the next couple of years or so. If I learn, if I learn things that are suited for the robotics industry, be it AI that assists in building, AI that goes into robotics or even mechatronics.
Yeah.
What kind of a salary package would you be offering me as a fresher?
I think it depends very much as a company and what.
Sure.
Because we want to hire top talent, we offer a very compelling sort of salary for a fresher. Somewhere on the ballpark of about 9 lakhs ish, 6 to 9, about 9 lakhs ish, you can say. Yeah.
Got it.
So yeah.
Guys pursuing engineering, if you are interested in robotics, be it the software side of robotics or mechatronics or hardware in general. So as Raviteja puts it, there's a lot of opportunities there. There's not enough talent and there is requirement. Salary packages starting at 6 LPA is a very good package out of college. So if you need information on where to learn these things from, you can always reach out to us. We'll help you find the right pathways for that. So I think we've covered a lot of topics, from your personal journeys to your co-founders to your company and everything. What's your ultimate vision for Perceptyne?
Like I said, be that robot which can do anything that you say.
That's a great closing point. Thank you, Ravi, for joining us. Exceptional story, exceptional team. We wish you all the best. And for our viewers, if someone is interested in investing in your company, what is the pathway?
Yeah, just reach out to us.
So you are going through a fundraise. You are going through a fundraise now, then.
Yeah, I mean, not actively, but definitely.
Yeah, so if someone is offering you money, you won't deny it.
Yeah, we won't deny it.
All right, fair enough. Thank you, Ravi. Thank you so much for joining us.
Thank you.
Pleasure talking to you.